Next example, we're going to look at some right angle triangles and try to work out some trigonometry there. So we're given that a right triangle has short sides of length 3 and 4, and we're trying to find the tangents and cotangents of all the angles in the triangle. So the first thing we need to do is figure out what the hypotenuse of this triangle is. So we know that the hypotenuse squared is 3 squared plus 4 squared, which is 9 plus 16, which is 25. So the hypotenuse must be 5 units long. So let me figure out, first of all, the tangents of all the angles in the triangle. And we're going to use SOHCAHTOA. Remember, tangent equals opposite over adjacent. So the tangent of theta is the opposite over the adjacent, which is 3 over 4. The tangent of phi is the opposite side of phi, which is 4 over 3. And then the last angle in the triangle is 90 degrees, so that's the tangent of pi over 2 radians. But remember, the tangent is undefined for pi over 2, so I'm just going to leave that as undefined. That's because tangent is sine over cosine, and cosine of pi over 2 is 0. So now cotangent of each of these angles. Cotangent is just the opposite of tangent in the sense that when tangent is sine over cosine, cotangent is cosine over sine. So the cotangent of theta, instead of being 3 over 4, will be 4 over 3. And the cotangent of phi, instead of being 4 over 3, will be 3 over 4. And the cotangent of pi over 2, which is the cosine over the sine, so that's 0 over 1, is just 0. So the secret to working out tangents and cotangents of angles in right triangles is just to remember the SOHCAHTOA formula. In particular, the TOA part says tangent equals opposite over adjacent, so that quickly helps you figure out the tangents of angles in right triangles.